Here we're going to try what I call a solution problem. Back when I was an educator in the classroom, I found that these problems were the most difficult for my students. So I wanted to make a couple videos doing solution problems where we solve for different parts of the problem, if you will. And so here's the first one I want to talk about. So I'm going to take a step back. I want you to press pause and I want you to attempt this problem first and then check back in to see the answer. Okay, so here is what I think is the best approach. Here's what I think is the best approach to these problems. Well, first we should probably read it. So solution A is 25% acid and solution B is 50% acid. If you have 12 milliliters of solution A, how much of solution B must you mix with it in order to get a solution that is 35% acid? So for these types of problems, I think it's important to understand what exactly is going on. So let's draw a picture. We have one solution here. We're adding a certain amount of solution B. So we'll call this solution A, and we'll call this solution B, okay? And then that's going to give us, a final solution. I guess we could just call it solution C, if you will. And we know how much of A we have. We want to know how much of B to mix with it to get a certain solution C, which is 35% acid. So let's start off putting what we know in here. So we know this is 25% acid and solution B was 50% acid, and we want something that is 35% acid. Okay? So let's think about what's going on here. I'm going to get some other colors here. The first thing I'm going to tell you to do is get these percents in decimal form, okay? We know 35% means 35 over 100, 50% means 50 over 100, etc. So I'm going to put that on top. So 25% is 0.25, this is going to be 0.50, and this is going to be 0.35, okay? Now on the bottom, we should write how many milliliters we have. So we're told that we have 12 milliliters of solution A. So we're going to put 12 down here, okay, 12 milliliters. Here we have X milliliters because we don't know. It asks how much of solution B must we mix. So we don't know. And then what's solution C going to be? Well, think about it. We've got 12 milliliters of solution A, X milliliters of solution B. We are combining them to get this final solution, this solution C. So that means it's just going to be 12 plus X, right? The original 12 milliliters of solution A, and then we pour in a certain amount. So whatever that certain amount is, we're adding it to the 12. Okay. Now the one thing is I don't want you to memorize this process because if you just memorize it, you might not really understand it. So let's talk about what's really going on and how we can illustrate this situation mathematically. So, basically what I need to know is how much acid is there. Let's think about it, how many milliliters of acid, right? So how could I find out how many milliliters of acid are in solution A? Well, if it's a 25% solution, that means 25% of the total number of milliliters you have is milliliters of acid. So we could illustrate that as 0.25 times 12, okay? And that's going to be milliliters of acid, okay? That right there. That's how many milliliters of acid. Because think about it. If we know how many milliliters of acid plus the additional amount of milliliters of acid, that's going to equal the amount of milliliters of acid in the final solution. So let's do that with the second one right here. We are adding to that 0.5 times X. Okay? So I can even put the X in parentheses if you want, if you like that. Okay? So 0.25 times 12 plus 0.5 times X equals, and again, how much acid is in this final solution? Well, it's 35% acid. So it's going to be 0.35 times however many milliliters are in the final solution. Okay, so now this is actually pretty easy. We only have one variable, which is awesome. Okay, so 0.25 times 12. Now, some of you might be like, oh my gosh, decimals, what do I do? So I think it's good to just be like, wait a second. 0.25 is just 1/4. So 1/4 times 12, well, that's the same as, so 1/4 times 12, okay, is just the same as 12 over 4, okay, which is 3, right? 12 divided by 4 is 3. Good. Then we have plus 0.5 times x is just 0.5x, okay, and then that equals, okay? So now this is where it gets a little more difficult here, so we're distributing this. This is where you might want a calculator. So 0.35 times 12. What is 0.35 times 12? So you can pause and kind of do that on your calculator, or what you can do, which is, you know, I mean, I guess it doesn't, well, so you could do 0.35 is really 35 over 100, okay? And we're multiplying that by 12, so we want to know what that is. So sometimes what I think is the easiest way is to just kind of write it all as a product of its prime factors. So this is 7 times 5 times 2 times 2 times 3 over, and then 100 is going to be 2 times 5 times 2 times 5, right? So then we get rid of the 2 2's, check you later. We get rid of a 5 here and a 5 here, so we're looking at 21 over 5, okay? Which, that's going to be, what, 4.2, I think? And you can check that in a calculator. We're just going to go with that, 4.2, okay? So then that's going to equal 4.2 plus 0.35x, okay? So then what we'll do is we will just... let's keep everything positive. So I'm going to subtract the 3 from both sides. Okay, so I end up with 0.5x equals 1.2 plus 0.35x. Okay, and then I'm running out of a little bit of room here, so you know what I'm going to do? I am going to erase this right here. Okay, so that I can move up there if necessary. Alrighty, so now I'm going to subtract 0.35 from both sides. Okay, so then this is going to be what? 0.15, so 0.15x equals 1.2. Okay, so I'm going to kind of come up here and write that up there. So I'll just write it again. Equals 1.2. Okay, now essentially all we're doing is we are going to divide both sides by 0.15x. So I'm sorry, not 0.15x, just 0.15 to isolate x. But again, you know, I do a lot of things without a calculator, so because I don't really have one with me right now. So I'm just going to multiply both sides by 10. So then I'm going to do that over here. So if I were to do that up here, actually maybe I should do it in another color so I don't confuse you. So what I want to do is just, you know, divide both sides by 0.15. Oh, not x. I don't know why I keep wanting to put the x there. Ah, no x. I want to keep the x alone. Okay. So 0.15. But because I don't have a calculator to do that, I'm going to do some side work over here. So if I multiply both sides by 10, I get 1.5x. By the way, you can always just do that and then skip this. But I think this is actually kind of cool number theory stuff. So then that's going to be 12. Okay. So then, okay, still kind of annoying to divide decimals. So what if I double both sides? Because if I double this, I'll get a nice number, 3. And I double that, I get 24. And then, oh, this is so nice. Divide both sides by 3. X equals 8. And for those of you using calculators, I'm sure you discovered that 1.2 divided by 0.15 is indeed 8. Okay? So, again, what you've heard me say before, which is word problem, word answer. So we solved for x. X was 8. So what does 8 mean? Well, remember, x was the number of milliliters of solution B. Okay? So let me see. I guess I'll erase this up here and I can write the answer up there. Okay. So what we're going to do here is we're going to write the answer, which is 8. Okay? And that is the number of milliliters of solution B, because that's what our variable was. So you need, so how much of solution B? Okay, so you need to mix 8 milliliters of solution B, oh no, with, I'm going to actually just kind of do with, because we're running out of room here, with the 12 milliliters of, and I'll abbreviate, solution A to get a 35% acid solution. Okay, so there's your answer. Now, just so you know, your teacher could take this one step farther and ask you, how many milliliters of this final solution do you have? So then that's pretty easy. If you mixed 12 milliliters with 8 milliliters, you would get 12 plus 8 milliliters, so you'd have 20 milliliters. So there you go.